Simplify each expression. Use absolute value symbols when necessary. Write all your answers without negative exponents. We have the sixth root of 6 times x to the 6th y to the negative 12th divided by 64 z to the 24th. The sixth root of 6 is not going to be simplified because I can't find a number multiplied to itself 6 times to give you 6. But x to the 6th, that would just be x. Y to the negative 12th, well, we can do a power to a power, and this is like a fractional exponent, so that'd be y to the negative 2. 64 happens to be 2 times 2 times 2 times 2 times 2 times 2, 6 of them. So I can take out a 2, and z to the 24th, I can think about this as dividing my exponents and get z to the 4th. And we still have some cleaning up to do. We have a negative exponent here, and we can't have any answers with negative exponents, so we'll bring that down to the denominator. And this index was even, which means that we do have to be aware of using absolute value symbols. They are necessary. We have x, sixth root of 6, divided by 2 y squared z to the 4th. So the absolute value bars are only necessary to guarantee that things are positive. The sixth root of 6 is still positive, 2 is positive, any number squared will be positive, any number raised to the 4th power will be positive, but it's this lonely x that I do not know whether or not it's positive, so I need to put in the bars to guarantee that. Let's look at another example. A to the 1/2 times a to the 1/3, all raised to the 6th power. Well, according to the order of operations, we're supposed to do inside parentheses first, and this is a to the 1/2 and a to the 1/3. But if you're multiplying, then you actually get to add exponents. But to add fractions, you need a common denominator. The common denominator would be 6, so if I multiply both top and bottom by 3 in that fraction and top and bottom by 2 in that fraction, I'll have a to the 3/6 times a to the 2/6. And let's not forget that all of this is being raised to the 6th power. So we'll leave that in there until we simplified the inside. By adding exponents, we get a to the 5/6. And this is being raised to the 6th power. So a power to a power, we can multiply exponents, in which case we'd be reducing. We'll have a to the 5th power. Now again, we don't have to worry about absolute value bars because none of our indexes were even.